Welcome to Lesson 1, Waves, from the section on Light and Sound. And today, we are going to do Lesson 1, Part 1, which is all about periodic time and frequency. These are two very important concepts in physics. You're going to be using these throughout your physics course. Make sure you have your notes downloaded. The theme is periodic time and frequency. We've already talked about oscillators in part 1 of this lesson. And what's an oscillator? Oscillators make waves. They're objects that go back and forward, to and fro. A good example that you know well would be a pendulum. So when you pull the pendulum back, it goes back and forth. Or another good example would be a mass on a spring. You pull the mass down, and it starts moving up and down. It's oscillating. So, here's my pendulum. That's its central or mean position. If you pull it back to A and let it go, well, you know what's going to happen. It's going to move across to B and then back to A. And it's going to keep on doing that. Back and forward movement. To go from A all the way across to B and then back to A, we call that a full cycle. And the time it takes to make one full cycle, that's called the periodic time. We call that capital T. Let's say in this particular example, the periodic time is 0.4 of a second. What does that mean? Well, let's say it's at A right now. Well, that's 0 seconds. I let it go. It goes to its central position. That'll take 0.1 of a second. Then it goes across to B. That'll take another 0.1 seconds. Now we're up to 0.2 seconds. It'll come back to its central position, 0.3 seconds. And finally back to A. That'll be 0.4 seconds. The periodic time is the time it takes for a complete cycle. Let's analyze that motion in more detail. So here I've got the 5 positions of my pendulum. So position 1, it's in its central position. Then it's going to move back to the right to position 2. As it moves to the right, we call that its displacement from its central position. The displacement from its central position is put on a graph here. Displacement is on the y-axis. The maximum displacement, which is the furthest it goes back before it stops, that's called the amplitude, and we're going to call the amplitude A. So what would be a definition of the amplitude? The amplitude would be the maximum displacement from its central position. Let's have a look at the example in your notes. I want you to draw this particular graph with me. They're telling me here that the maximum displacement from the central position is A. And they're telling me that that maximum displacement is 1 centimeter. That's the furthest it goes back to the right or to the left. They're also telling me, as I've already said, that the periodic time, the time for a complete cycle, is 0.4 seconds. So you can fill in here what the periodic time is and what the amplitude is. So in this particular example, the amplitude A is equal to 1 centimeter. They're also telling me that the periodic time T is 0.4 seconds. I want to draw a graph from that situation. So let's have a look here. There it is in position 1. Its displacement from its central position is 0. That's when we're starting our stopwatch. T is equal to 0. So time is along this axis here, time in seconds. So therefore, in position 1, it's got 0 displacement at 0 seconds. So that dot there represents position 1. Now it starts moving out to the right. So its displacement grows and grows. It takes 0.1 seconds to reach its maximum displacement or its amplitude, which is 1 centimeter. So look at what happens during that 0.1 seconds. The graph will grow like that. And the highest point is at 1 centimeter. So this here represents position 2 on my graph. And then when you move on to position 3, now the pendulum goes back in position 3 to its central position. Its displacement once again has become 0. So then over the next 0.1 of a second, it goes down like this. This here represents position 3. Now what happens? Well, next thing, it starts moving out to the left. It moves out to the left, and once again, its maximum displacement to the left is the amplitude. Now, because it's moving to the left, I'm going to have to show it going under the x-axis. So over the next 0.1 of a second, it goes down to minus 1 centimeter. It's minus because it's going in the opposite direction. But the amplitude is always the absolute value, which is 1 centimeter. So right down here, I have position number 4. And then finally, to complete the cycle, it goes to position 5, so it arrives back in its central position. So finishing it off, goes there, and that there represents position 5. You see the graph represents 1 full cycle of the pendulum. This here, if I shade it in, that there is 1 full cycle. The time it takes to complete that 1 cycle, that is, well, have a look at your graph. The time it takes to do 1 full cycle, that there is 0.4 seconds. So just looking at your graph, periodic time t is 0.4 seconds. And then, of course, what's going to happen now? It's just going to continue on its way. So the next 0.4 seconds, it's going to make a full cycle again to 0.8 seconds. And then it's going to make another cycle again over the next 0.4 seconds, which gives me eventually 1.2. So you can see I've completed 3 full waves in 1.2 seconds. You can see the amplitude from the graph as well. The amplitude is the height of the graph, the maximum height of the graph. That there represents the amplitude A. And you can see by going across there, that's 1 centimeter. Or in the opposite direction, it's minus 1 centimeter. But take the absolute value of it. So just by looking at the graph, I can see that the periodic time t is 0.4 seconds. Next, I'm going to look at something very closely related to that. Something very closely related to that is the frequency. What does the frequency stand for? The frequency stands for the number of waves or cycles per second. There is 1 second there. How many full waves do you see in that 1 second? Well, we've got 1 full wave there up and down. Here's another full wave up and down. And finally, I've got this half a wave here when I arrive at 1 second. So you can see by looking at your graph that the frequency is 2.5 or 2.5 waves per second. Waves per second or cycles per second. We give that special units. The special units I give that are things called hertz. HZ, called after a famous scientist. So hertz represent the units of frequency. Now, you should also be able to see this. There's a simple relationship between frequency and periodic time. The frequency is 2.5. The periodic time is 0.4. The frequency, f, is actually equal to 1 over t. Because what's time? 0.4. What's 1 over 0.4? Put that into your calculator in your head. You'll get an answer of 2.5 hertz. So here's our first formula. We're going to be using the formula F is equal to 1 over T. Or you can manipulate that formula and write it down in terms of T. You can also write down T is equal to 1 over F. Going back to our notes. Here's your formula that we talked about already. F equals 1 over T, or written another way, T is equal to 1 over F. You'll find that in your table book. You should actually highlight the formula in your table book. I know you can't bring it into the exam with you, but you're going to be using it for maybe 2 years. You will know exactly where every formula is. The formula in your table book is on page 54. Here's my table book. Go to page 54. And it's given in this format here. T is equal to 1 over F. It's also equal to 2 pi on omega, but we'll worry about that later on. Shade that in. You've got these definitions here. You have to learn definitions for your leaving cert. But a lot of my definitions have this asterisk or star beside them. And that means I could use the formula instead of the definition. So for example, the periodic time. You know what the periodic time is. You can use the words if you want. It's the time a vibrating object takes to make one complete oscillation. But I can also use the formula T is equal to 1 over F. Now, if you use the formula instead of the words for the definition, you've also got to do what's called the notation. You've got to write down beside them, what does frequency stand for? And what are its units? What does periodic time stand for? And what are its units? So, if you want to get full marks, and you want to give a definition as a formula, make sure you put the notation in as well. Here's your definition for frequency. It's got a star beside it, so you can use the formula for frequency. And you know what it is anyway. It's the number of complete oscillations made in 1 second. Then we have the definition for amplitude. Well, you're just going to have to learn the definition for that. But it's easy. Once you understand it, you'll remember the definition very quickly. It's the maximum displacement of a particle from its central position. Let's have a look at example 1. It says from the graph, you want to calculate the following. We want to find the amplitude. Well, you know what the amplitude is? The amplitude is its maximum displacement. It'll be the high point of the graph. Just looking at your graph here, you can see that the amplitude will be that particular height there. The amplitude, looking at the scale here, the amplitude will be 10 centimeters. Part A, amplitude A is equal to 10 centimeters. Part B, they're asking me for the periodic time. You know what the periodic time is. It's the time for one complete cycle. So looking at my graph there, one complete cycle, start here, go across, finish here. Well, you can see just by looking at your graph, one full cycle going up and down, that will be 8 seconds. The periodic time is called T, is equal to 8 seconds. The next thing they're asking me to find is the frequency. The frequency is the number of waves in 1 second. You know, you could look at 1 second, which is around here, and see what fraction of a full wave has taken place. Bit hard to find in the graph. Let's use our formula. So what's our formula for frequency? Our formula is F is equal to 1 over T. Put my value of periodic time in, so it's 1 over 8. Put that into your calculator, and you will get 0.125. And what are the units of frequency? The units of frequency are hertz, 0.125 hertz. Part D, they're asking you to find the number of waves or cycles which pass a point in 64 seconds. Well, I already know from the periodic time, don't I, that one wave will pass in 8 seconds. The question is, how many waves will pass in 64 seconds? Well, if I multiply that side by 8, 8 by 8 is 64. And I'm going to multiply the other side by 8, and I get 8 waves will pass in 64 seconds. Part E. They're asking me the question, the time it takes for 20 waves to pass a point. Well, you already know here, don't you, that one wave takes 8 seconds. Well, why don't I multiply this side now by 20? So I get 20 waves, and multiply the other side by 20, and I get 160 seconds. So 20 waves will take 160 seconds to pass. Okay, that's the end of Lesson 1, Part 2.